Today, we'll dive into the critical concepts of access control and authentication, fundamental for digital security. Our focus will be on how we secure digital access and verify user identities in various systems. Let's explore the three fundamental authentication methods that form the bedrock of digital security today. These methods are broadly categorized by something you know, something you have, or something you are. First, we have knowledge-based authentication, which relies on information only the user should know. This method relies on something the user knows, such as a confidential password or a personal identification number. Next is possession-based authentication, where you must physically possess a specific item. It involves something the user physically has, like a security token or a registered mobile device. Finally, inherence-based authentication uses unique biological traits specific to the user. This method uses something the user inherently is, often a biometric attribute like a unique fingerprint. Now, let's move on to more advanced authentication approaches that enhance security beyond the basics. These methods go beyond just a simple username and password, offering greater protection. Multi-factor authentication, or MFA, is a robust approach combining multiple authentication types. It combines two or more distinct types of authentication factors for stronger verification. MFA makes it significantly more difficult for attackers to gain any unauthorized access to your accounts. A common example is using a password along with a fingerprint scan for enhanced security. Risk-based authentication, or RBA, dynamically adjusts security based on potential threats. This system dynamically adjusts the required authentication steps based on the assessed risk level. RBA analyzes factors such as user location, the device used, and typical user behavior patterns. If a high-risk attempt is detected, it triggers additional verification steps to confirm identity. Let's explore some key authentication protocols that form the backbone of secure digital interactions. These protocols are essential for creating a secure and trustworthy environment for all digital interactions. Kerberos is a powerful network authentication protocol using secret key cryptography for secure access. It provides robust network authentication by employing secret key cryptography to verify identities. Kerberos offers strong, mutual authentication, especially useful for client-server applications within networks. OAuth is an open standard that allows secure access delegation without sharing passwords directly. It's an open standard specifically designed for secure access delegation to protected resources. OAuth grants limited access to your resources without ever exposing your actual passwords. SAML, or Security Assertion Markup Language, facilitates the exchange of authentication and authorization data. It's a standard for exchanging authentication and authorization data between different security domains. SAML is widely adopted for implementing single sign-on, or SSO, solutions across various services. Radius is a centralized protocol for authentication, authorization, and accounting, known as AAA. It centralizes authentication, authorization, and accounting, commonly referred to as AAA services. Radius is commonly found in wireless networks and for managing remote access services securely. Today, we're diving into a crucial security concept. What exactly is multi-factor authentication, or MFA? MFA is a security process where you provide two or more verification factors to access resources, significantly boosting security. Let's explore the 5 fundamental factors that make up multi-factor authentication, enhancing our security posture. MFA works by intelligently combining various proofs of your identity to ensure only authorized access. The first factor is something you know, which is information only you should possess. This includes familiar elements like your passwords, PIN, and answers to security questions. Next, we have something you have, a physical item in your possession. Think of your smartphone, a hardware token, or even a smart card as examples here. Then there's something you are, which refers to your unique biological characteristics. This includes biometric data like your fingerprint, facial recognition, or an iris scan. Another factor is somewhere you are, focusing on your geographic location during authentication. This involves verifying your geographic location using details like IP addresses or GPS coordinates. Finally, we have something you do, which involves unique behavioral patterns. This could be your unique typing speed or even how you move your mouse on the screen. Now, let's understand why multi-factor authentication is an absolute must-have in today's digital world. MFA drastically reduces unauthorized access risk, even with stolen passwords, and helps comply with regulatory standards. Let's now explore the key access control models, which are fundamental frameworks for security. These models provide structured frameworks for managing precisely who can perform what actions within a system. First, we have discretionary access control, often abbreviated as DAC. In DAC, the resource owner holds full control over setting and modifying permissions. While flexible, DAC can sometimes be less secure due to its distributed permission management. Next, we examine mandatory access control, or MAC, a more rigid security model. Here, a central authority dictates all access based on strict, predefined security policies. MAC is highly secure and rigid, commonly deployed in environments with very sensitive data. Finally, we have role-based access control, widely known as RBAC. With RBAC, permissions are assigned to users based on their specific roles within an organization. RBAC is highly scalable and greatly simplifies the administrative overhead of managing access rights. Now, let's dive into understanding how the single sign-on, or SSO, process actually works in practice. The core idea here is simple. You use just one set of login credentials to access many different applications. The first step involves central authentication, which is the heart of the SSO system. When a user logs into one app, SSO verifies their credentials through a central server or identity provider. Next, SSO uses a system called token-based access to manage your identity securely. After successful authentication, SSO creates a digital token, which acts as your proof of identity and permissions. This token then enables seamless access across all your connected applications. With this token, you can access other applications instantly without needing to re-enter your login details. Now, let's explore federation, which is how we extend SSO capabilities across different security domains. Federation extends SSO, letting users access resources across different organizations or systems without multiple logins, thanks to trusted relationships and standard protocols. Let's summarize the key concepts we've covered in this lecture on access control and authentication. Here are the essential takeaways and key points that you should remember from our discussion today. Remember, authentication confirms identity using factors like something you know, something you have, or something you are. Multi-factor authentication, or MFA, greatly boosts security by requiring two or more distinct authentication factors. Access control models, like DAC, MAC, and RBAC, dictate precisely how users obtain access to various resources. Single sign-on, or SSO, streamlines access, enabling you to use just one login for many different applications. Federation extends SSO, allowing seamless access across various organizational domains, promoting secure collaboration. Finally, remember that balancing strong security with user convenience is an ongoing challenge in access management.